Hello and thank you for taking the time to watch Omni Embedded's Vtrek introduction video. The Vtrek package consists of the embedded code set, the Testdriven Development platform, the Prodav tool, and the DDC tool. It's targeted for ARM core processors using the GNU compiler, GDB, and the Eclipse IDE. Omni Embedded has a growing number of ports for processor models and vendors. You can also create your own port by using one of the existing ports as a reference. The Test-Driven Development platform is an excellent platform for software component development and testing. The Prodav tool makes setup and coding a snap, and the DDC is a must-have for debugging, tuning, and testing on target hardware. The embedded code set is pattern-based and well-structured. All source files follow a predefined format and appearance. Everything from the hardware abstraction block upwards is the same, no matter the processor model or vendor. I/O and data mapping are accomplished through the Prodav tool and configuration of software components, so there's no hard-coded mapping. The data center and RTI work together to create a unique event-driven solution that eliminates race conditions and data convergence issues. A rich library of commonly needed workhorse utility classes and functions, along with several services, are included in this package. In the services block, we have communication support, file storage, which includes wear-out leveling and redundant storage, mode services, and fault tracking service. In hardware interfaces, we have general purpose I/O. This includes debounce filtering and logic correction, analog inputs with optional digital filtering, all of the common timer functions, communication support that includes CAN, LIN, and Ethernet, and on-chip flash erase and writes. In the Utilities toolbox, we have a number of containers available, code automation, closed-loop control support, data center support, and data processing functions. This is a powerful collection of classes, and it's a culmination of functions that we found are commonly needed in embedded product development over the years. The Prodav tool is a product development companion. You can easily start new projects for your selected processor. In this case, we're selecting a starter project for the NXP Kinetis K64. You can select the software components from the library that you need in the build. Notice that the K64 starter project already has a debug and release builds. Of course, you can add more builds to your configuration, and this tool will pick those up. You can map and configure I/O through configuration forms. In this example, we're showing configuration for digital outputs. All of this type of configuration data is stored in a const structure in a C++ file in your build, so you can modify and update settings there as well. You can map and configure data flow. In this form, we're showing the data dictionary in the data center, where all of the shared variables reside. You can view a map that relates all of the data items in the data center to the software components that use them. And you can add and delete data items from this view as well. Data items are also stored in a constant structure in a CPP file, so you can perform the same operations manually through a source editor. You can add new source code files to your project using file templates, and you can add your own templates to the list. And you can add code snippets for source files using the snippets tool. And of course you can add your own snippets as well. DDC is a communication protocol that supports product development, debug, and field service tools. You can use debug printing in source code and the trace window to trace code flow and behavior. You can log trace data to file from this window, and you can also set up string filters. You can monitor the workload through the RTI window. For each task, you can see the percentage of stack used, average, maximum, and minimum task periods, and average and maximum runtime, as well as the average percent CPU utilization. At the bottom, you can see the overall percent utilization of the CPU, and this data is updated every 10 seconds. You can interact with services such as mode service. This is a service where you can put your embedded code into various modes of operation, and you can do it from a DDC tool in order to test those modes. And you can monitor, chart, and control data signals from the Data Center Variables window. From this form, you can see that the DDC tool has uploaded the data dictionary, so all data items are visible in the left side of the window. You can display a variable as text, either fixed location or scrolling, or you can chart variables to give a visual viewing. You can set the color of the signal. And you can create control panels where you can hijack these signals and control them from the DDC tool. And lastly, you can use the DDC DLL to create your own test scripts for product testing and your own applications for field support, such as software updates, extracting fault statistics, and so forth. The Test-Driven Development Platform is a C++ code set using Microsoft Community 2019. This platform provides resources to simulate an embedded environment that builds and runs the Vtrek code. New software components can be developed and tested on the platform first and then move to the actual target hardware build. Coding and debug in this environment is much faster than on an embedded environment. And since this is a simulation environment, you can simulate conditions that can be difficult on real hardware. The platform has its own I/O abstraction layer, or HWA, that's ported to the unit test platform and the Vtrek source code. It also provides RTOS simulation, which means that you can test code down to the RTOS tick rate. And just as we saw with the DDC tool, on this development platform, you can interact with data items in the data center to provide stimulus and response measurement. When you create a new project in Prodav, a copy of this platform is placed in your workspace. All of the test scripts that are used to build Vtrek components are already in the project. There's also a playback engine and simulators in the build, and you can add additional simulators as needed. And test utilities provide the resources to manipulate the unit under test. If you have team members working at a remote location, it's entirely possible to do a great deal of development with this test platform without the need for any of your product hardware. So what's the result? Well, your team's work product has a consistent look and feel due to the use of patterns. Using the TDD platform to create and test new software components saves time, increases quality, and enables remote developers. Using Prodav to map I/O and data flow, configure components, create new code files from templates, and adding snippets saves a ton of time. Using the DDC tool to develop, debug, and tune your code saves a ton of time as well. And you save a ton of development costs. Thanks again for watching this video. For more information, please go to omniembedded.com.